Okay, so for this question, we want you to rank the materials according to their refractive indices in ascending order. And essentially what we're asking you to do is to compare how much each of these rays is bending towards or away from the normal. So if we've got light refracting through material, we need to consider Snell's law. So N1 sine theta 1 equals N2 sine theta 2. Because remember, how much something bends towards or away from the normal is going to give us an indicator of the ratio of the refractive indices of the material. So if the ray is passing from one material into another and then it bends towards or away from the normal, we can say whether that second material has a higher or lower refractive index compared to the first material. And that is essentially what we are going to be doing here. So I'm just going to draw a bunch of normals in here. And by process of elimination, we're going to be able to work out which materials have higher refractive indices. Okay, so I'm just going to put in some angles here. So this is theta AI, theta BR, BR for refractive. This is theta BI for incident, and so on. Okay, so let's just look at this first bit. So by looking at the ray as it goes from material A to material B, we can see here that theta AI is going to be larger than theta BR, right? It's bending towards the normal. That must mean that the refractive index of A, is it going to be higher or lower than that of B? Well, it has to be lower than that of B because in material B, the ray is traveling slower, which is why it bends towards the normal. Okay. So for this next part, we can see that we have theta BI, and it is much, much less than theta CR. The refractive angle is quite large. So because of this, we know that the refractive index of material C has to be a lot less than that of material B. So let's go back into this next bit. And so we have theta CI, which is going to be much, much greater than theta DR. That must mean that the refractive index of C is going to be less than the refractive index of D. In fact, we can also make a judgment call about the refractive index of D compared to the refractive index of C. Because remember, if we were to send the light in the other direction, the angles still hold. It doesn't matter if we're sending the light in this way or this way, the angles are still going to hold. But let's think about if we're coming back the other way, because theta CR equals theta CI. These are exactly the same angles. So here we've got the exact same case, but we're sending it this way. Now theta BI is actually greater than theta DR. Therefore, the refractive index of B must be less than the refractive index of D. D has to have the highest refractive index. And let's have a look here. We can say theta DI is going to be less than theta AR. Therefore, the refractive index of D has to be greater than the refractive index of A. Okay, so we got a lot of things going on here. Let's try and put them together. So we have, I'll do it over here. So we have now, the only thing we don't know right now is what's the comparison between material C and material A. Now, just like our reasoning before, comparing D and B, we can compare C and A via the material B. So what's happening is this angle CR, the way that the ray refracts when it enters material C is greater than when it enters material A, if we were to send this ray in the other direction. Therefore, the refractive index of C must be less than that of A. So I think we're getting a bit of a clear picture here. What it looks like is we've got C first, and then we have material A, then we have material B, then we have material D.